So we'll start with some definitions. First, we'll talk about an outcome. An outcome is just when we are performing some type of experiment, and whatever happens as a result is called the outcome. And then we can group these outcomes as what are called events. Now, this is usually pretty tricky for people because it seems like they're kind of the same thing. But an event it can be a more complicated thing than an outcome. So, for example, suppose I'm drawing a card from a deck of cards, and the outcomes then would be all the different individual cards. Okay. However, we could group them and say, well, if I draw a heart, there's 13 different outcomes that classify as drawing a heart, which would make the drawing a heart an event. A simple event is the most basic type of event that you could have. And so that would be kind of like an outcome. That would be, drawing the three of hearts is a simple event because there's no way to break that down into simpler ways. Now, when we look at all the different possible simple events that can occur, this is called the sample space. Okay, it's the set of all those different possibilities. So the sample space for drawing a card from a standard 52 card deck would be this set of all those 52 cards. Let's look at an example. If we roll a standard 6-sided die, describe the sample space and some simple events. So the sample space, this is generally written as S, okay, equals, and then we usually do it in curly brackets if we can. We'll list out all those simple events in the sample space. So the things that can happen that when you roll a 6-sided die, we can get a 1, a 2, a 3, a 4, a 5, and a 6. Okay, so that's the sample space. And then some simple events would be anything like rolling a 1, rolling a 3, rolling a 4. Okay, those are our simple events. Now, with those definitions, we're ready to actually talk about the probability of an event. So if all the outcomes are equally likely, then we compute the probability of an event E using this notation. So P of E, this is the probability of the event E occurring. And the way we calculate that is we take the number of outcomes that correspond to the event E and then divide that by the total number of equally likely outcomes. So a very basic example, if I'm rolling a 6-sided die and I want to know the probability of rolling a 1, I say, well, how many ways can I roll a 1? There's only 1. How many total things can happen when I roll a die? Well, there's 6 possibilities. So 1 over 6 is the probability of rolling a 1. Formalize that here with our example we just talked about. So the probability of rolling a 1, equals the number of ways a 1 can be rolled divided by the number of possible rolls. Okay, so the number of ways you can roll a 1 is 1, and the number of possible rolls is 6. Okay, let's go a little bit more complicated. Let's do this. The probability of rolling a number bigger than 5. So we need the number of ways it's possible. Bigger than a 4. Number of ways to roll bigger than 4 divided by the number of possible rolls. Okay, so the number of ways to roll bigger than 4 is we can either roll a 5 or a 6. So that's 2 ways. And then divided by the number of possible rolls, which is 6. So 2/6 or 1/3. Let's look at another example. Let's say you have a bag with 20 cherries, 14 sweet and 6 sour. If you pick a cherry at random, what is the probability that it will be sweet? So the probability of a sweet cherry is the number of ways to pick a sweet cherry divided by the number of ways to pick any cherry. Okay. So the number of ways to pick a sweet cherry, there's 14 sweet cherries, so there's 14 possibilities there. And then divide by the number of ways to pick a cherry, well, there's 20 possibilities there, so divide by 20. So 14 out of 20, or 7/10, or 0.7. Compute the probability of randomly drawing one card from a deck and getting an ace. Okay, so the probability of getting an ace, that's going to be the number of ways to draw an ace, so number of aces, and then divide by the number of total ways to draw, so that's divide by the number of cards. Okay, so there are 4 aces, and there are 52 cards in a standard deck. So 4 out of 52, or 1 out of 13. Okay, there are just a couple of special types of events to know about. First is an impossible event, and an impossible event is just one where the probability is 0, meaning there are no ways for that event to occur. And then a certain event is on the opposite side of the spectrum. That's something that has a probability of 1, meaning no matter what, that event will occur.